Hello, I'm Marika Bogdani and I'm an investigator at Benaroya Research Institute in Seattle, Washington. I grew up in Albania, where I graduated with an MD from the University of Tirana. I trained at the Free University of Brussels in Belgium, where I first started studying type 1 diabetes and came to Benaroya Research Institute several years ago. The overall goal of my work at Benaroya Research Institute is to identify the earliest islet changes that take place in people who get type 1 diabetes before they have symptoms, and in particular, to understand what role the extracellular matrix plays in the development of type 1 diabetes. Specifically, the goal of this project is to discover the early changes that take place in human islet ECM that may initiate immune cell attack, resulting in insulin cell loss and ultimately type 1 diabetes. I need to introduce a few concepts to help explain how exciting this work is. First, let's talk about the extracellular matrix, or ECM. The ECM is basically a layer of goo that surrounds the cells in all of your tissues and organs. Each tissue has its own unique ECM. It can be made of different components based on what the cells or tissues need in order to function. Here, the jello is the ECM, and it's helping support the fruit, which are like your cells in any tissue of the body. The cells that make insulin, called beta cells, are in structured environments called islets in the pancreas. Islet structures have their own specific ECM that's different from that of other tissues. And one of its main components is hyaluronan, or HA. Here, the highlighted area indicates the islet periphery, and you can see an islet with its normal ECM surrounding it and within the islet. This green staining shows that there is normally a little bit of HA in the ECM of an islet. But here is an islet from someone with type 1 diabetes. This large amount of green staining indicates a huge amount of HA in this islet. I recently showed that islets from people with type 1 diabetes have a modified ECM with more HA, and this impacts the way the immune system interacts with islets. I'm interested in understanding what role the ECM plays in type 1 diabetes development and learning what we can do to fix the ECM. In order to do this, I want to understand, first, what changes in the ECM at the very earliest stages of type 1 diabetes. Second, when is the best time to intervene in the disease? And third, which cells make these changes to the ECM? Now, you may be wondering what I mean by the early stages of type 1 diabetes. The earliest sign of type 1 diabetes is when someone has an autoantibody directed against one single beta cell protein. This antibody signifies that the immune system has started to respond inappropriately to beta cells. Most people who go on to get type 1 diabetes will move from having one autoantibody to having autoantibodies to two or more beta cell proteins. This point, when someone has two or more autoantibodies, is defined as the start of type 1 diabetes, or stage 1 type 1 diabetes, even though they do not have any symptoms or they are not on insulin therapy. This is because almost everyone with two or more autoantibodies will progress to stage 2, dysglycemia, and eventually stage 3 when the person starts taking insulin. My earlier work showed that the ECM is different here, at stage 3 and stage 4, at and after diagnosis. But now I want to know what happens to the ECM when people have very early disease, with only one or two autoantibodies. To do this, first I will determine the changes in the islet ECM that take place very early in type 1 diabetes. I will measure how much HA is in the islet ECM of people with one or multiple antibodies. I expect that islets from people with one antibody who are really early on and might never get the disease will look like this, where HA is bright green and the islet is in orange, and there is a pretty small amount of HA. I predict that this islet comes from someone with two or more autoantibodies, and thus are much closer to being diagnosed with type 1 diabetes, because they have much more HA deposited in their islets. The next thing I want to understand is when the increase in the amounts of HA occurs in relation to the start of immune cell attack of the islet. To do this, I'll determine whether or not people have immune cells accumulated next to or within islets, indicating they are attacking the islet, as illustrated here. I predict that very early in the disease, not only will there be very little HA in the islet ECM, there also won't be any invading immune cells, like in a normal islet. My hypothesis is that HA buildup is needed for immune cells to attack. So I expect that people who are partway through the disease process will have HA buildup but still no immune cells. And that late in the disease process, when people have multiple autoantibodies and are close to type 1 diabetes, they will have much more HA and will also start to see the invading immune cells. Finally, I want to understand which cells are making the HA that we see in the islet ECM. Islets are actually composed of quite a few different cell types, and I want to figure out which ones are producing the HA. Are they the endocrine cells, shown here, or the mesenchymal cells, shown here? Finding out which cells make HA will help us understand the very earliest steps in development of type 1 diabetes. This might give us a target to modify those earliest steps with the goal of preventing type 1 diabetes. This project is critically important for many reasons. First, ECM is a novel research area. We know that ECM is important to the way that every cell functions. However, it is not understood how ECM functions in type 1 diabetes. This project will help us understand whether ECM changes very early in the disease process. If it does, this could be a transformative early intervention and could lead us to prevention and ultimately a cure for type 1 diabetes. We think that the ECM is a missing puzzle piece that can help us better understand disease progression and immune cell attack. To summarize, I am asking 3 questions and hoping to get 3 really important answers. We will learn what changes occur to the ECM. This is important because without knowing what changes in the ECM, we won't know what to fix. Further, we'll learn when is the earliest point that we can intervene in the disease. And finally, we'll know which cells make HA, because we want to target the right cells at the right time in order to develop the right therapies.
Thank you very much for considering our project.